So we're going to talk today about absolute value equations. We've been working with different algebraic equations and expressions for this unit, and we're going to talk today about equations that involve the absolute value symbol. So as a reminder, absolute value symbol means that we're talking about the distance a number is from zero. So for example, if I give you something like this, the absolute value of 5, we would say that that is equal to 5 because 5 is 5 spots away from 0 on the number line. For the same reason, -5, the absolute value of -5 is also 5 because if I draw a number line, I still count 5 spaces to go from -5 and get to 0. So again, absolute value is talking about the distance of a number from 0. So if we have an absolute value equation, that means we're talking about an equation that contains an absolute value symbol. So in this case, we have the absolute value of x equals 12. So there are some values of x that would satisfy this equation. What are they? So we could basically, what could we plug into x that would make this statement true? And there's two choices. If we look at what I put up before, what might my two choices be for what I could put in for x? So x could equal positive 12 or x could equal -12. Another way of writing that you might see is plus or minus 12, which is the same thing. So that means positive or -12, plus or minus 12. And we know that because 12 and -12 are the two numbers that are 12 spots away from 0 on the number line. What values of x would satisfy this equation? So how can I do this? Because we have an absolute value equation here that says the absolute value of 3x equals 6. So what could I plug in there that's going to give me a positive 6? Essentially what I'm asking is, what can I put in for x that's going to satisfy this? But even without saying that, I want to know what could I plug in for this whole thing that's going to give me an absolute value of 6. And there are two numbers, again, there are two numbers that will give me an absolute value of 6. What are they? -6 or positive 6. So that means I'm looking for the value of x that could essentially make this expression right here equal either -6 or positive 6. So what number can I plug in for x that would make that equal to -6? In that case, x would be equal to -2. Or if I want to make it positive 6, then x would have to be equal to positive 2, because 3 times positive 2 would give me positive 6. So I can go through and I can kind of guess and check my way there because I'm looking at that and I know it's multiplication. I know this right here means 3 times x. So I'm asking myself, okay, 3 times what number is going to give me a positive 6 or a -6? And then I'm ultimately coming to x has to be -2 or positive 2. How could we do that algebraically though? If I don't want to just guess and check my way there, because again, we've talked about this before. A lot of things can be done mentally, but as you start to get more and more complicated, it's difficult to keep track of things mentally. So we like to have an algebraic way that we can solve them so we can keep track of everything that we're doing in an algebraic way. So how can we solve this algebraically? Well, again, as a reminder, our two values that are going to give us positive 6 are the absolute value of -6 or the absolute value of positive 6. So it could be either plus or minus. And again, another way we can write that is plus or minus 6. So if you hear me say that, that's what that means. So we have plus or minus 6. So if I want to do that algebraically, then essentially I'm looking for a way to, quote, get rid of those absolute value signs. Because in algebra, we've talked about this, we always want to sort of isolate the x, right? Get rid of the things that are around it. And one of the things that are around it here are absolute value symbols. So the way that we eliminate those absolute value symbols is by saying, okay, well, I know that I don't just have one option. That means I have two options. That means I have 3x could be equal to positive 6, or 3x could be equal to -6. And that's what's going to allow me to eliminate or isolate the x there, that's what's going to allow me to eliminate that absolute value sign. So what did I do? I took what was inside the absolute value sign, which is 3x, so I took that expression, 3x, and I made it equal to positive 6, and I made it equal to negative 6. And again, the reason that we did that is because you have two options for how you can get to positive 6 if you're taking the absolute value. It's either positive 6 or negative 6. And then, now to isolate the x even further, I need to get rid of that 3. So I divide by 3 on both sides, and I get x equals 2, or divide by 3 over here, and I get x equals negative 2. So to solve this algebraically, that's what I'm going to do there. So what would I do here? Here I have the absolute value of 2x equals 3. So what would I do here? If I want to write it algebraically, I've got two options. I want to eliminate those absolute value signs, so I write it 2x equals positive 3, or 2x equals negative 3. And again, I'm not done yet because my x's are not isolated. So to keep isolating, what do? I divide by 2 on both sides, and I get x equals 3/2. Or if I do the same thing over here, I get x equals negative 3/2. You can write those as decimals. If you do write them as decimals, it would be 1.5, negative 1.5, or you can just leave it as a fraction. Either one is fine. I prefer improper fractions because it's less work. All right, so I would like you to try these at your boards. So the practice problems here are going to involve those absolute value equations. And again, every one of these should have two options. Every one of these should have two options. So go back for a second. You take what's inside the absolute value function, so 2x right here, and you make it equal to both positive 3 and negative 3, because those are your potentials for what you could possibly get a positive 3 as your outcome. Okay, so now that you've done the practice problems, let's go over a couple of them just as a review. So we're going to go over number 4, and we're going to go over number 5. So number 4 says absolute value of x over 7 equals 3. So what are my two equations that I'm going to end up with when I eliminate those absolute value symbols? I have x over 7 equals positive 3, and x over 7 equals negative 3. And then to isolate x, this means what? This is a fraction, and every fraction is just a division problem. So to isolate x, I'm going to multiply by 7 over 1, and then I do that on this side as well. I end up crossing out my 7's on that side, so I have x by itself, and then on the right side, I have 21. And then I do the same thing over here, so times 7 over 1 times 7 over 1. And as a reminder, we do 7 over 1 because we use the reciprocal of that fraction. 7 was on the bottom, so we need it on the top, and we use 1 as a placeholder. We don't really need that 1, it's just using it as a placeholder. So my 7's go away, and I get x equals negative 21, because negative 3 times 7 is negative 21. For number 5, we had the absolute value of 7 plus p equals 7. So my two equations are going to be what? 7 plus p equals positive 7, or 7 plus p equals negative 7. Now to get rid of, or to isolate this p, I want to get rid of this positive 7 here, so I'm going to do minus 7, and that gives me p equals 0. Or I'm going to do minus 7, and that gives me p equals negative 14. You'll notice that when you do addition, when you're doing addition or subtraction problems, unlike when we were using multiplication where division, all of them gave us just a negative and positive version of itself, when you're doing addition and subtraction, you might end up with two totally different answers. But if you think about it and go back and plug it in, it makes sense because 7 plus 0 is equal to positive 7. And 7 plus negative 14 is equal to negative 7. So either way, that's getting you to 7 when you take the absolute value. All right, what's happening in here? So in this equation, we have a much longer equation. We have 3 absolute value of 4x minus 5 minus 2 equals 19. So I've got a couple things going on here. I have an absolute value expression, but I also have other stuff. I have a positive 3 being multiplied, and I have a negative 2 or a minus 2. So I need to first isolate the absolute value expression. So before I can do any of my absolute value math, I need to isolate that expression. So that means I need to get rid of the 3, and I need to get rid of the 2. And just like when we were isolating variables in our algebraic equations before, to do that, I want to get rid of, remember, those weak antelopes, those ones that are off to the side by themselves. I want to get rid of those first. So the first thing I'm going to get rid of here is the minus 2. So I get rid of a minus 2 by adding 2 to both sides. And I end up with 21 equals, my 2's are gone. So now I have 3 absolute value of 4x minus 5. I still have the absolute value symbols. I have not done anything to get rid of those. Remember, those only eliminate when you split it into 2 separate equations. So now I need to get rid of this 3. And again, if we remind ourselves that absolute value symbols act kind of like parentheses, then that means this is no symbol in there. When it's right next to a parentheses, we assume that it's multiplication. So to get rid of that 3, I'm going to divide on both sides. And I end up with 4x minus 5, the absolute value of that, equals 7. And now I have an absolute value expression by itself on the left side. So now I can break that into 2 different equations. So remember, we break it into 4x minus 5 equals positive 7, and 4x minus 5 equals negative 7. And that's going to allow me to eliminate those absolute value signs. And now I just isolate the variable. So this is a 2-step algebra problem, just like what we've done before. So I'm going to add 5 to both sides. And I get 4x equals 12. And then I divide by 4. So I get x equals 3. Over here, I'm going to add 5 to both sides. And I get 4x equals negative 2, divide by 4, x equals negative 2 over 4, or negative 1/2, or negative 0.5. Any of those are correct. So depending on how you do that on your calculator, you might get a different answer. How can you check this? So the way that we can check this is to go back and plug it in, but we want to plug it in at the very beginning. So we would go back and plug 3 in at the very beginning, and then we go back and plug negative 1/2 in at the very beginning. So 3 or negative 1/2. And if I plug in 3, I've got 4 times 3, which is 12. 12 minus 5 is 7. 7 times 3 is 21. 21 minus 2 is 19. If I do negative 1/2, I have 4 times negative 1/2, which is negative 2. Negative 2 minus 5 is negative 7. The absolute value of negative 7 is positive 7. 3 times 7 is 21. 21 minus 2 is 19. So again, we can always check our work by plugging in, but you want to go back and plug in at the very beginning to make sure that you were right. All right, let's try this one. So before we can split it, before we can eliminate the absolute value signs, I've got to get rid of that fraction. So how do I get rid of a multiplied by a fraction? I multiply by the reciprocal on both sides. So I'm going to multiply by 2 over 1, 2 over 1. That eliminates, and I end up with absolute value of x plus 2 equals 20 over 1, but I don't need that 1 there. So now it splits into 2. And I get x plus 2 equals 20, or x plus 2 equals negative 20. I finish this by subtracting 2 on all the sides, and I end up with x equals 18, or x equals negative 22. If I plug that back in, I will see that either way that will give me 10 when I plug it back in. So negative 22 plus 2 gives me negative 20. Absolute value of negative 20 is positive 20, and half of 20 is 10. 18 plus 2 gives me 20. 20 absolute value is 20. Half of 20 is 10. All right, so go ahead up to your boards and try these practice problems.